All right, let's go ahead and continue with the next part about discrete random variables. So in the previous videos, we saw that a random variable can be described by listing all of the outcomes as well as the corresponding probability for that outcome. And what we want to do now is we want to talk about two other items, and those are the expected value of a random variable as well as the variance of a random variable. So here is an illustrative example. Let's suppose that I'm going to go ahead and pick a ball from the bag that is shown here to the right. And the random variable of interest is simply the number that is on the ball. So we have that x, my random variable, is the value that is written on the ball. So if we go ahead and pick one, you can see that if we get a ball, for example, here, that the value on the ball is 1. So therefore, that is the potential value of this random variable. The probability is 0.5. And the way that we get that is that there are 1, 2, 3, 4, and 5 balls in this bag out of 10. So 0.5 comes from 5 out of 10. Another value could be 4. So that's this ball here. That's this ball. And there's only 2 of them. So that's how we get 2 out of 10, which is 0.2. And finally, the last value that we could get on the ball is 7. Now, here's what I want to talk about. The formula for the expected value is basically taking the value of the random variable and multiplying it with the corresponding probability. It is obtained by multiplying the rows right here. So we have the value of 1, and you would multiply it with p. You would then go to the next value of the random variable. So that would be 4. So you take 4 and multiply that with 0.2. And you do that for all possible values of your random variable. So if I were to write this out, this formula, I get 1 times 0.5 plus 4 times 0.2 plus 7 times 0.3. And you just add up all of those products. Now, this number, once you throw this into a calculator and get a number, is known as the expected value for the random variable. It is very closely related to the average value. So you can tell that the notation that we're using is the Greek letter mu, same as population mean, introduced in earlier sections. Now, there's a reason for that. Let's go ahead and rewrite this 0.5 as 5 out of 10. And in the 4, that'll be 4 times 2 out of 10, and the 7 times 3 out of 10. So notice that I simply went ahead and reverted to the frequency, the relative frequency, to obtain this. Now, all of these are over 10, so this second line is actually equivalent to if you put everything over 1 and then multiply. So that'll be 1 times 5 plus 4 times 2 plus 7 times 3, all divided by 10. And if you look closely, we're just adding up a bunch of different things. Here is the reason why. The outcome that we see is 1. And there are 5 of those possible. So you get 1 plus 1 plus 1 plus 1 plus 1. Then we get one of the outcomes here is 4, and there are 2 of those balls. And then we can see that the outcome here is 7, and there are 3 of those. So this is actually just the sample mean of that bag, of all of the potential outcomes in that bag. So notice that there is a difference here. If I had taken a sample, then mu is the actual sample mean, but I'm describing the potential outcomes. In other words, the value of the ball that is drawn. And that's why it's called the expected value. That it, when you use the word expected value, you're actually describing the experiment. But when you use the word mean, you're describing a sample. So let me just write that down. So whenever you see the word mu, a lot of times that describes samples. But when you use the word mu of x, and there's a little x at the bottom, there's a little difference. Or if you use e of x, then that describes an experiment. All right. Now, the word for expected value is really important because it really does say that on average, you expect the value of your random variable to be, or we expect. So the interpretation is over many trials of the experiment, the actual average, so basically think of the red, will be approximately the expected value of the random variable, which again, we're going to write as mu sub x. All right, let's go ahead and see what we mean by this. So this is part of the interpretation here. I'm going to go ahead and use StackCrunch to simulate this, just to give this meaning, again, because we're saying over many trials here. And what we're going to do is we're going to simulate. So type this little table into StackCrunch. So if we do that, we see that here we have our outcomes, which are 1, 4, and 7. Leaves 0.5, 0.2, and then 0.3. Yeah. All right, we're going to label this X, and we're going to label the other column P of X. So I basically just went ahead and typed in my distribution in StackCrunch. Then you're going to follow these instructions here. That's going to say data simulate custom. Select your values of X and the weights as the probabilities. Now, I can go ahead and change the rows. The row says how many times are we going to pretend that you're doing this experiment. So I'm going to start with 10, and then I'm going to select column as 1. So notice that I get a new column here. And this basically is indicating that we simulated, we pretended we actually did draw a ball from this bag following this distribution. So we reached in here and we picked one of these balls and we got a 7. We did it again, we get a 7 again. Do it again, get us another 7. Wow, so 3 7s in a row. Now the fourth one is a 1, and so is the fifth. And the sixth draw is a 4. And we get 2 more 7s, then a 4, then a 1. Now notice that here I basically picked repeatedly, and the value of the random variable alternated between 7, 1, 4, and then, oh wow, surprisingly 7, 4, 1. So let's go ahead and do this again. Instead of 10, let's do something more like 50. And notice that now we have more entries here, where we have more trials or simulations of my experiment. And what the random variable tells you is basically what you can expect. So if we go back to our interpretation, it's that over many trials or many attempts at my experiment, if you record that, then the average value of the values that you obtain will be very close to mu of x. So here I did it myself when I wrote the notes, and I did it for 10 times, 50, then 100, 500, 1,000, 5,000, and finally 10,000 times. And then I went ahead and just simply recorded the statistics. Remember, we can get that by going to stats, summary stats, columns. You select the columns that you want. And really, I'm just interested in the size, mean, and standard deviation. And here's what I observed, that when I did 10 trials of this, the average value that I got on the ball was 4.6. The next time that I did it, when it was 50 times, I observed an average of 2.68. And you can see here that when I did this separately, the values are shown here, right? So our means are here. And so this is what we're talking about, that over many, many trials, if you were to simply take your average of whatever you observed, we can actually, even though this is random, we actually have a pretty good idea of what the values will be quote unquote centered around. All right, now the way we actually compute this is very easy in StatCrunch. So this is how you actually compute it. So we'll compute mu of x and sigma of x, the standard deviation, using StatCrunch. And it's very easy. You got to type in your distribution, same thing that we did here. So you just need this x and p of x. And then we're going to go to stats, calculator, custom. Select your x and p of x, press compute, and this is it. You're done. Because we have the mean right here, and that actually is mu sub x. And then we have the standard deviation, which is actually sigma sub x. So we've already seen this in the previous section when we were asked to find the distribution as a graph. So we can see that the distribution as a graph is here. And so convenient that right below that, we also have the mean as well as the standard deviation. And so that wraps it up for us. If we take a look at our notes, I believe that that is all that we have. Awesome. All right, so in the next video, we'll go ahead and do a complete example. All right, I'll see you in that one.